Lesson 1-6 talks about multiplying and dividing real numbers. We've already reviewed most of these rules just when we've been evaluating and doing other things, but this lesson will specifically go over the rules just in case you've missed any. First thing you need to know is what the identity property of multiplication is. And the identity property of multiplication is similar to the addition property, the identity property of addition. When you add 0 to something, it doesn't change. So stop and think about what wouldn't change if you multiplied. And it would be multiplying by 1. When we multiply by 1, nothing changes. So if I was to multiply 5 times 1, I just have 5. 1 times negative 6, I would just have negative 6. Then there's the multiplication property of 0. If you don't know what this property is, you probably can figure it out just by looking at the name of it. What happens when you multiply something by 0? That's right, it becomes 0. So if I had something like 2.5 times 0, 0. Negative 7 times 0, 0. So no matter what it is, it becomes 0. And then there's the multiplication property of negative 1. This is a really important one to use sometimes, especially when you're solving equations. And if you think about what happens when you multiply by a negative 1, it doesn't stay the same. It actually becomes the opposite. So if I have negative 2 and I want to make it positive, I can multiply it by a negative 1 and I have positive 2. If I had a positive 4, wanted to make it negative, multiply it by a negative 1 and I have a negative 4. So that's always going to switch the sign when you multiply by negatives, by negative 1. Okay, quick review on the rules. Multiplying numbers with the same sign. Two positives always stay positive. This is where it's a little bit different than adding and subtracting, so you just have to be careful. Two negatives, also a positive. So for every two negatives that you multiply, you end up with a positive. If you're multiplying two negatives, you have positive. Three negatives, you'd be back at negative. Four negatives, positive. Five negatives, back at negative. So when you stop and look at it, you kind of want to think of the rule. An even number of negatives equals a positive answer. This is when we're multiplying or dividing. So it's different than adding. Oops, sorry. Odd number of negatives is going to be a negative answer. Because there's that one negative left over without something to cancel and become positive. So if I had something like 2 times a negative 8, positive times a negative, nothing to cancel, it's an odd number of negatives, so negative 16. If I had something like 2 times negative 3 times negative 4, when I go to look at this, I usually determine my sign before I even write an answer or do any of the multiplication here. 2 negatives are going to become positive, and then another positive just stays positive. Now I multiply 2 times 3, and then 3 times 4, so I end up with a positive 24. Now we're going to do some evaluating. Same thing, we've been doing this all of chapter 1 so far. You're just evaluating with some multiplication to practice a little more. So if I said evaluate negative 2xy for x equals negative 20 and y equals negative 3. You want to use that rule we've already talked about before. Just don't forget parentheses. So it's just more practice with that. So go ahead and try it, and then start the video again when you're ready to check it. So I have a negative 2, and then I'm multiplying that by a negative 20 and a negative 3. So when I go to look for my solution here, negative, 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 I have 3 negatives, so these cancel, become a positive, but then I have 1 more negative. So my final answer is still going to be negative, so I go ahead and write that now so I don't forget it. And then I go do the actual multiplication. So 2 times 20 is 40, 40 times 3 is 120. Alright, now we're going to be looking at a couple exponential expressions. Again, we've already talked about this, but it's another quick review just to remember. So the big thing is don't forget parentheses, include the sign. So for example, if I had negative 3 to the 4th, remember, that negative, I'm not looking at the negative 4 times. It's just negative. Now I go multiply 3 times 3 times 3 times 3. So if you want, you could put a 1 there, and then 1, 2, 3, 4 3s, if you're thinking about it that way. And if I multiply 3 times 3 times 3 times 3, I end up with a negative 81. So this, the negative stays. Versus if I was to put negative 3 to the 4th, now I'm actually looking at negative 4 times. So negative, negative becomes a positive, and then another set of negative, negative becomes positive. Even number, so I have a positive answer, and then 3 times 3 times 3 times 3, which is negative, or positive 81. The other way to look at this, if you start to get confused about these, negative 3 times negative 3 times negative 3 times negative 3. Negative comes with it each time. Here there's only one of them. Here the parentheses include that, so there's 4 of them. So negative times negative times negative times negative is a positive, and then we know 3 to the 4th power is 81. So on this one, the negative is included. And what you're going to notice is the same rule here. 4 of them, positive. 5 of them, you'd have an extra, negative. So that same rule applies with the exponents there. Okay, and here's the really nice thing. When we're talking about dividing real numbers, same rules as multiplication. So you don't have to remember different rules, you just apply them the exact same way. The properties are the same also, but they're by division. When you're looking at dividing by 1, the number stays the same. So let's just do an evaluating example with division. Negative x over 4 plus 2y divided by r. For x equals a negative 20, y equals 6, and r equals negative 1. So first thing you want to do is just go plug everything in. Remember, this negative is not the same here. It's a negative and I plug in a negative 20. So I have negative 20 over 4 plus 2 times 6 divided by negative 1. So they're all put in parentheses. Now I'm going to follow order of operations. Don't forget order of operations. So I've got an addition here. This is division and this is division. Division comes before addition, multiplication comes before division. So I know in the end I'm going to multiply and then divide. Here I know I'm going to divide, then I get to add whatever these become. So I have a negative times a negative, which is a positive. So I have 20 over 4, because that's multiplication, plus 2 times 6 is 12, divided by negative 1. And I dropped my parentheses here now because I noticed there was nothing I needed to look at there with it, like this. And now I go do the division. So 20 divided by 4 is 5, plus 12 divided by negative 1. Okay, here's where you don't want to accidentally add this and then divide. Instead, you want to do your division first. So 12 divided by negative 1 is a negative 12. And this is actually going to change what you would have had if you had added then divided. So now I have opposite signs I'm adding. Sign from the larger of the two absolute values, which would be negative. And then you find the difference. And it's 7. Alright, there is an inverse property that you're going to need to know about when you're using fractions mainly. So this is the inverse property of multiplication. If I had a 5 and I wanted that to become a 1, stop and think about what you could multiply it by to get it to be equal to 1. and some of you might have figured out that it would be 1 over 5. So now, if you notice, 5 times 1 is 5, 5 over 5 is 1. So the inverse property of multiplication is multiply by the reciprocal. And remember, reciprocal is just the fraction flipped. This is actually like a 5 over 1 becomes a 1 over 5. So if I was to give you 2/3, what would you multiply that by to make it a 1? Most of you should have said 3 over 2. Reciprocal. These 3's become a 1, these 2's become a 1. 1 over 1 is 1. And remember, these aren't zeros, they're 1's. So you're going to need to remember this for solving equations. Alright, and our last example for this lesson, this looks really confusing, but if you stop and think about it and what it means, most of you would be able to figure this out. If they ask you to evaluate, and in this case it looks like a nice easy problem, just x over y. Stop and think, x over y actually represents what? You should say division. But now when they ask us to do that, they say, by the way, x equals a negative 3/4 and y equals a negative 5/2. So when you go to evaluate this, it's going to look really crazy because now I have negative 3/4 divided by negative 5/2. And a lot of students get stuck here, they're not sure what to do. But I just used the key word, negative 3/4 divided by negative 5/2. So this just means divided by, so I'm going to rewrite it, negative 3 over 4 divided by negative 5 over 2. And now every single one of you knows what to do. So division rule for fractions is we flip the second reciprocal and then multiply. So negative 3/4, but then it becomes times negative 2/5. So we multiply by the reciprocal, and it's always the second one. So once you do that, you can either simplify before or you can simplify after. I notice 2 goes into 2 once and 2 goes into 4 twice. Negative times a negative is a positive, so I know I have a positive answer. 3 times 1 is 3, and 2 times 5 is 10. And then I always check this to make sure my fraction doesn't simplify further. And in this case, it doesn't. And that's the end of lesson 1-6.